what's widely regarded as the most successful theory in the collapse tradition is this GRW theory, various of its close relatives. And what's widely regarded as the most successful theory in this extra variable tradition is Bohm's so-called hidden variable theory. Good. There's also a third tradition, where a tradition that traces back to Everett, where you try to avoid both horns of this dilemma. You try to insist that the wave function is a complete description of the world at a time, and also to insist that the dynamical laws that you find in the original quantum mechanical algorithm are exactly correct. So then you say, okay, but then how does this work? What explains the fact that when I go measure the position of an electron, which is initially in a superposition of being here and here, I find it either here or there? Proposed answer, something very weird happens when you do this measurement. Nothing happens to the electron you measured. Something weird happens to you. You split into two selves, one of whom sees the electron here and the other of whom sees the electron there. Okay? And that's how to understand what the traditional algorithm is telling us. These are called Everettian, or more colorfully, many worlds attempts to solve the measurement problem. This comprises the third major tradition of attempts to solve the measurement problem. This would be done without actually tweaking the mathematics of the theory in any way. It would be done by re-understanding in a realistic way, okay? In a way, so the idea here is, no, we're not going to be like Bohr. Quantum mechanics tells us a complete theory of the world, okay? Gives us a complete description of the world, including measuring instruments, including observers, so on and so forth. The way you're going to solve the problem is by granting that the story that it does tell us about the world, which is a universal, complete, traditionally, philosophically realistic picture of the world, is that the realistic picture it's describing is incredibly wacky. Okay, we're splitting. Okay,
yeah.
There really are two. It really was the case that before we looked, there wasn't a fact of the matter about where the particle is, and as soon as we do look, there are two particles and two of us, one of which saw it here, the other of which saw it there. Blah blah blah. Good. Aside from being wacky, which is not a good reason to reject a theory, especially in the weird dark waters that we're facing, that we're navigating in quantum mechanics. But there are concerns, and I would say I have concerns, about whether this third tradition even ends up being logically coherent. Okay? That's a long story. There's a lot to say about it, but